GeopByte.
Dear students, now let us discuss the previous year questions for the very small and important unit, that is gravitation. Okay, from this very small unit, you can expect two questions for the NEET exam. That means, though it is a very small unit, two questions can be expected. That is the weightage of this particular unit for the NEET exam. Okay. So I hope all of you clearly understood all the theory concepts what we discussed for gravitation. Understood or not? Yes. Then let us take the very first question without wasting the time. Look at the very first question asking like this. The escape velocity for Earth is v, a planet having 9 times the mass that of Earth and radius 16 times that of Earth has the escape velocity. It is given that the escape velocity of an object on Earth is v, and he is asking escape velocity of the same object on a planet in terms of v. He is asking. Okay. Now, a planet, that planet is having the mass of the planet is 9 times the mass of the Earth. And the radius of the planet is 16 times the radius of the Earth. Then, as you know, the general formula for deciding the escape velocity equal to root over 2gm by r. From this, I can write that escape velocity of the object on earth is root over 2g mass of the earth divided by radius of the earth. Now let me decide the escape velocity of the same object on a planet is equal to root over 2g mass of the planet divided by radius of the planet. It is equal to root over 2g constant. Mass of the planet is 9 times the mass of the earth divided by radius of the planet is 16 times the radius of the earth. Now you simplify it. Here it is written as 9 by 16. Let me write outside 2g me by re. Okay. So the escape velocity on a planet is equal to 9 by 16 root over can be written as 3 by 4 into root over 2g me by re. But 2g me by re equal to escape velocity of the object on the earth. That is equal to 3 4 times the escape velocity of the object on the earth. But that is given as v. That is given as v. Therefore, escape velocity of an object on a planet is equal to of a planet is equal to 3 by 4 times the v. Okay. Look at the option C, 3 by 4 times the v. Option C is absolutely correct. Understood clearly? Yes. Then look at the another important question asking like this. An object of mass 100 kg falls from a point A to point B. Look at the point A and B. Point B. As shown in figure, the change in its weight corrected to the nearest integer RE by the radius of the earth. So you are asked to decide the change in weight of the object by the time it is falling from A to B. Further, as you know, the weight general formula, weight of an object at an elevated height mg equal to or mg dash equal to mg dash equal to mg into r square by r plus h whole square. That is the general formula. Now, let me decide the weight at B, weight of object at A first. At A is equal to mg dash at A equal to mg into r square by at A is the h. R square by r plus h. H equal to what? 2r. 2r whole square. Now you simplify it. So weight of the object at A is equal to mg r square by r plus 2r 3r whole square. 3r whole square. It is equal to mg r square by 9r square. Of course, here 9 can be, r square can be cancelled. Here mg dash, weight of the object at A is equal to mg by 9. Similarly, at B, look at the height corresponding to B. This is the height corresponding to B. This is the height corresponding to B. The height corresponding to B equal to right 2RE 2RE minus RE by 2. RE by 2. It is equal to 4RE minus RE by 2. It is 3 by 2 RE. 3 by 2 RE. That is the height corresponding to B. Then weight at B, mg dash at B is equal to mg into r square by r plus h whole square. It is equal to mg into r square by r plus h. H equal to what? H equal 3 by 2 RE. 3 by 2 RE I am writing as r whole square. This part whole square. It is equal to mg into r square divided by here it is 2r plus 3r by 2 whole square. Now you simplify it. It is mg into 4r square, that 4 goes up, into 5r whole square. It is equal to 4 by 25 mg r square by r square. This r square part is cancelled. Finally, it is 4 by 25 mg. Okay. Now, you are asked to decide what is the change in weight. Change in weight equal to change in weight is equal to weight at B minus weight at A. That is mg dash at B minus mg dash at A. mg dash at B is 4 by 25 mg minus mg by 9. mg by 9. You simplify it. Let me write the mg outside. Here it is 4 by 25 minus 1 by 9. It is equal to mg into, right, let us take LCM. 25 into 9. 9 4 36 minus 25. It is equal to mg. Here it is 11 by 25 into 9. Okay. Now it is equal to m value. What is the m value given? Mass is given 1000. G 9.81. 1000 into 9. Now 1000 or 100? 100 kg only. Be very careful. Here it is 100 into G 9.81, approximately 10. 10 into 11 by 25 into 9. You simplify this value for getting approximately 49. That is the approximate change in weight of the object. Right? 49 newtons. Option A is absolutely correct. Understood clearly? I tried to explain the each and every point at your understanding level. Understood or not? Yes.
GeopByte.